Okay, welcome to the next lesson for Math 9. Properties of chords in a circle. You'll find on page 392 is where this begins. The activity I'm going to start with is just my own activity. It's not really the same as what they're doing on page 392. So, chords in a circle. I've made a circle here with the diameter. The diameter could be placed a bit better. It's not quite in the middle of the circle. A little too far up in the upper part. But it'll serve our purpose for now. So the diameter is a line segment going all the way across the center of the circle, whether it's from this direction or from this direction or wherever. It doesn't really matter as long as it's going across the middle. A chord is any other segment of a circle that doesn't cross the middle, such as this is a chord, and there's a chord. Okay, they're going all the way across the circle, but not at the circle's widest point, not across the middle. Okay, therefore they're not diameters, they are chords. So that's a diameter, that's a chord. Now, the next concept that we're going to be looking at is a perpendicular bisector of a chord. But first of all, here we'll label this one a diameter. We'll label this one a bisector. And this one a bisector. Just ignore me, I'm doing some math recording. This one a bisector. Sorry, if they'll hit you falsch, and the lesson has barely begun. Now, where's my whiteout? These are not bisectors, they're chords. Bisector is the next concept. So far, I've sketched a diameter and two chords. That's a chord. That's a chord. So you probably want to pause and make this correction right now. Otherwise it'll get confusing. So, a perpendicular bisector. Bi means two, and a bisector is something that bisects a line, or really anything else, into two equal parts. And a very simple way to get a perpendicular bisector of a chord is to draw it straight down from the center of our circle. Boom! There we have a perpendicular bisector of a chord. Here and here. Two perpendicular bisectors of a chord. Now, what is unique about this? First of all, let's record it. A perpendicular bisector. It cuts our chord into two equal parts, and every time we have a perpendicular bisector, it forms a 90-degree angle with the chord, because it's coming right straight down from the middle of the circle. And if it is a perpendicular bisector, if it is dividing our chord into two equal parts, it's a 90-degree angle. Perpendicular means two lines, remember, from previous, that come together to form a right angle. So, let's record then the definition. Definitions. Diameter a line across the center of the circle. A chord any line across the circle. That is not going across the center. That is not going across the center. Last definition. A perpendicular bisector divides a chord into two equal parts and forms a right angle. Perpendicular bisector. All right, you'll find similar definitions on page 393, but let's review them quickly. There's our diagram, chord, diameter, and perpendicular bisector with the 90-degree angles, and bisecting it exactly in the middle. And how do you know that you're bisecting it exactly in the middle? You come down from the center point of your circle. Okay. Diameter, a line across the center of the circle. Chord, any line across the circle that is not going across the center. So anything other than the diameter, as long as it's going all the way across. Perpendicular bisector divides a chord into two equal parts and forms a right angle. Let's have a look at and the last one. I just want to point this out. Of course, I've said it, but it joins the chord to the center of the circle. That's why it's perpendicular, because it's coming from the center. Okay. Just want to be sure we're pointing that out. Now, let's go to a couple of examples. And here's how I'd like to do this particular example. You'll find it on page 394. So I'd like to put this sheet here. Point O is the center of the circle. Line segment OC bisects chord AB. Okay. And OAC equals 33 degrees. Determine the values of X and Y. Well, if we have a perpendicular bisector, then we have two equal sides here. And if this is the center, then these two guys are radiuses. This one and this one. So they have to be the same length as well. So we have what kind of a triangle here? Page 394, example 1. It's an isosceles triangle. Okay. Therefore, angle X, this angle over here is going to be equal to angle A. Therefore, angle A is equal to angle B. Therefore, X is 33 degrees. Sorry, I wasn't showing my sheet here. So an isosceles triangle, angle A is therefore equal to angle B, and X is then 33 degrees. What's this angle then? We have a perpendicular bisector. Remember what a perpendicular bisector of a chord does? It forms a right angle. So right here we have a 90-degree angle. So how can we find y? The old 180-degree triangle property. 180 minus 90 minus 33. $57. And we can say, therefore, y equals 57 degrees. Good? Those are the answers they have, so we're good. Let's have a look at another example. Page 395. Point O is the center of the circle here. AB is the diameter with length 26, that's this guy. CD is a chord that is 10 centimeters from the center of the circle. So this chord comes down here, or no, this one, sorry. CD is a chord. And what is the length of CD? Give the answer to the nearest tenth. Let's have a look at the information that we have here. First of all, we can form, I'm going to use a pencil, I'll just erase it after. We know that this here is a right angle. So if we do this, not my most accurate drawing once again. We'll leave it. So this here, this is the diameter, 26. This guy's also coming from the center, but halfway to the outside. He is a radius. So if the diameter is 26, then this line here is a radius, has to be 13. So we've now essentially created a triangle with a right angle. One side is 10. We already knew this side is 13. We can find this side. So we are going to find the shortest side. We're going to find side A. So let's do the math on this. Page 394, example 1. Sorry. 395, example 2, and it is Pythagoras that we're using. Greek guy. And we're doing a squared plus b squared equals c squared. We're trying to find side a squared. And then we have a 10 squared, and our longest side is 13 squared. So we'll just work out the math. A squared, 10 squared is 100, 13 squared is 169. then we're going to have to, because we know what the long side is, we're going to subtract 8.3. Now, that's just the one side of the triangle. Let's take a look again. It's only halfway, but that little 10 centimeter line is a perpendicular bisector. So all we have to do is multiply by 2 to get the full length of chord CD. Okay? So, therefore, chord CD equals 8.3 times 2. It's 8 times 2 is 16. 3 times 2 is 6. Full length of that chord is 16.6 centimeters of chord CD. Yeah, let's do another one. Let's do one more example. And then we'll talk about what we're doing for exercises. This will be on page 396. And let's take a look at what they're asking us to do. A horizontal pipe has a circular cross-section with center O. Its radius is 20 centimeters. Water fills less than 1/2 of the pipe. The surface of the water, AB, is 24 centimeters wide. Determine the maximum depth of the water, which is the depth CD. So we're looking for this depth here. See that? And let's look at what we have. We know that this guy is a radius, so he's going to be 20. The radius is 20 centimeters, right? Now, this guy coming down is a radius as well. He's coming from the center, going all the way to the outside. He is a radius as well. So we have 20 centimeters here and 20 centimeters here, and we have a right angle here. And we also know the surface of the water, AB, is 24 centimeters. From here to here is 24 centimeters. And we know that this guy is a perpendicular bisector, right? So then what's the halfway point here? 12. Right? Can anyone see what we're doing yet? We now have a right angle triangle with one side 20, one side 12. We know that this full length here is 20. We can now find the length of this side all the way down to the water, right? Because this here is a right angle triangle above the water. So we can use Pythagoras to find the length of this unknown side here down to the water. And once we have the length of that side, we'll subtract it from 20. And that'll give us the depth, that last little bit here. Because we already know the total. We know the total is 20 because this is a radius just like this is. So we'll find the length down to the right angle using Pythagoras. Then we'll subtract that answer from 20. Because we know that this guy is 20 in total through all the way to the outside. So, page 396, the horizontal pipe. A squared plus B squared equals C squared. We this time know the shortest side, That's 12 squared. We're trying to find the middle side, which is B, and we do know C is 20. 12 squared is 144 at B squared. 20 squared is 400. 400 take away 144. 400 take away 100 is 300. 300 take away what? 40? 44. So 300, let's do 40 first. 300 take away 40 is 60. 60 take away 4 is 56. So that's 256. And our last step is to find the square root. $16. That's the length of that side all the way down to the water. Remember, the radius is 20, and that thing's also a radius. 20 minus 16 is 4. And we can say then that therefore CD, or the depth of the water, equals 4. Exercises are all going to be on the same page for this one. Page 397. Number 3, 4, 5, and 6. And before we get to that, I'm just going to give you a heads up that our next lesson is going to be the mid-unit review. The mid-unit review. And so, make sure you're aware of that. It'll be a brief recording, but quite a bit of work for you to do, because it's going to be the next assignment that counts for marks. So, let's look at those exercises closely. This is 397 right here. Here's number 1. Point O is the center of the circle. Find D, E, and F. Here you are to find the angle at D. I'm hoping that's not hard, right? You can see what kind of angle that is. Here we have a perpendicular bisector. 1/2 is 5, so the other half, well, it's got to be. Here we have a full chord. That's 14. So the 2 halves of the chord will be. Here we have, once again, point O is the center of the circle. We know that on this triangle here we have a 90-degree angle right there, because that's the perpendicular bisector, and we know this is 40. Solve for x. 180 degrees, remember? Our friend the isosceles. If this guy is 22, what's this guy? The same, right? And then our old friend 180 degrees to find y. C, 4C. They're giving us an angle of 110. You should immediately see that this is another isosceles triangle. So the big angle is 110, and these two angles are going to be equal to each other. So again, just do what we always do to find that. 5. Point O is the center of each circle. Determine each value of A and B. Well, this time we've got ourselves a triangle with one side 10 and the short side 3. So we can use Pythagoras to find this side A here, and then side B will just be the same. Yep. Here we want to find A and then B. So again, we can use Pythagoras to find this unknown side here. right? And once we have this unknown side, to find the full length of the chord, this is a perpendicular bisector, just double it. Once you've done a squared plus b squared equals c squared with a triangle, just bit of a freeze up here. Once you've done a squared plus b squared equals c squared with the triangle, just double your answer to find b. And 6. Of which there's only one question. Point O is the center of the circle. Determine the value of B. Which circle properties did you use? Well, we're looking for B here. We've got a perpendicular bisector. So it pretty well becomes clear what we need to do. We have one side that's 5. We don't know the other two sides. We need to find this one. There's a way of finding this one. The diameter here is 18. This guy here going from the center to the outside is a radius. So this guy here, the halfway, the long side of the triangle, half of 18 is 9. So now you have two sides of the triangle. You can use Pythagoras to find the third side. And guess what? Once you have this, side B is the same because it's a perpendicular bisector. So again, 397, 3, 4, 5, and 6. And then you have your mid-unit review coming up, which I'm not going to talk about today. I'll do that using a separate recording. That's it for this lesson.